In this problem, we have to calculate what is the charge enclosed within a cube. So what's given is the electric field. So if you look at this problem, the electric field is given. The value of the electric field is right here. You can notice two things here. The electric field is not a constant quantity. It is dependent on the y value. The other thing, it is oriented only along the y direction. There's no any electric field in any other direction. For example, the electric field has only this direction. So all the electric fields has this orientation, only coming out of this end. Or the electric flux is passing only through this phase here. There's no electric field coming out through this surface, even through this surface, because this one is oriented at y equals to 0. So all the electric flux is only passing through the top face. So how do you use the Gauss law to calculate the charge enclosed within the cube? What does the Gauss law tell you? This law tells you the total charge enclosed within a closed surface, the total flux, is given by Q enclosed divided by epsilon naught. We know this is a constant quantity. Alright? So what do we need to know now? So we have to find this this integral here. But the life is so easier here if you just pay attention. So this is the electric field, and if you look, this one is the elementary area. So as I mentioned, the electric field only passes through the top face. There is no electric field coming out of this surface, or through this surface, or to the back surface. So let's find out what is the electric field value at this top here, the top side. I can write down here. At top face or y with the value, this of the length or the height is given. Each side has 0.080 meter. So the electric field value at the top, I'm just writing down here, is given by 3280 times 0.080. So just have to calculate this number here. The number you will get is 262.4 Newton per coulomb. That's the number you get. Which means this value, this is the electric field value of this top surface here. We now have the electric field value. Now how do we calculate the total flux? The total flux is passing only through this area. So the total flux we denote this total flux by phi is the electric field at that point times the area. This area. Okay. This is exactly the same thing here, because there is no electric field passing through this surface, through this surface, through this surface, or to the back surface. The electric field is passing only through this surface here. Now, and the area has the same orientation as the electric field. these two are parallel. So the electric field value at this point is 262.4 times, what is the area at this point? The area is 0.080 times 0.080. Remember, just to be more specific, what I'm going to write down here, a J vector times here, just to be more specific, because both are oriented along the y direction. That's why I'm taking J vector and J vector here. Let's now, and this is the total flux. Let's calculate this number now. So this flux has to be equal to the charge enclosed divided by epsilon naught. And whatever the number you get, 262.4 times 0.080 times 0.080. J dot J vector is 1. And we can solve the value of Q enclosed. If we solve, let me write down here. And Q enclosed, if we solve this one, the value, the number you get is 1.48 times 10 to the negative 11 coulomb. This is the value you get. And you remember, this epsilon naught is a constant quantity, okay, which is given right here. Use this value, 8.85 times 10 to the negative 12 coulomb square, Newton per meter square. Alright, so this is the charge enclosed within the key.